In Chapter 9, Exercise 16, you want to use the molarity as a conversion factor. So remember that molarity is a unit for concentration. It's the number of moles of something that you have in a liter of solution. That's the molarity, and the symbol that will make you recognize molarity is a capital M, and it's read molar. So in this example, they're asking us to calculate, so this is what they want. We want to calculate the grams of solute. So that's the unit we're looking for, grams of solute, to prepare each of the following. Now, the number they give us, the first number they give us, is 2 liters. So we have 2 liters of this solution. An abbreviation for solution is SOLN. So if you ever see SOLN, that just means solution. So it's a short way of writing it. So 2 liters of solution, and we want grams, and the only other information that they give us is that the solution is 1.5 molar. So this is 1.5 molar NaOH solution. Now NaOH here is the solute. That's the thing that you're sprinkling in to the liquid in order to make it a solution, a mixture of different stuff. So that NaOH here is really what we want grams of. It's the solute. Okay, the first step for these is to break down molarity into its simpler units. So here, we know that molarity is moles of solute per liter of solution. So what we're going to have is that same number, 1.5, but that many moles of solute, so that many moles of NaOH. Whatever number goes in front of the molarity is the number of moles you have per 1 liter, per liter. So molarity is moles of solute per liter. So you just rewrite that with the number they give you in front of the capital M on top of this fraction. And now we can use that fraction as a conversion factor. We can see connections. So for example, the 2 liters that they give us, we can connect that with the liters here and get to moles of NaOH. But then we would need to get from moles of NaOH to grams. So in other words, we need a conversion factor that relates moles of NaOH to grams of NaOH. Anytime you relate moles to grams, you want to use the molar mass. That's the mass of 1 mole. And we can find that from the periodic table. So first, list each of the elements you have. We have sodium, oxygen, and hydrogen. In 1 mole of NaOH, we have 1 mole of sodium, because the number at the bottom right of the sodium is a 1. Nothing is written there, and so it's an implied 1. Each sodium, you would go to the periodic table and look, and underneath the Na, you would see 23. That's the molar mass. It's the mass of 1 mole of sodium. Each mole of sodium. Because we only have 1 mole, each mole weighs 23 grams. We only have that 1 mole, so total that'll be 23 grams coming from the sodium. Okay, let's go to the oxygen. In 1 mole of NaOH, we would have, look at the bottom right of oxygen, 1 mole of oxygen. And you know it's 1 because nothing is written at the bottom right of oxygen, so it's an implied 1. Then go to the periodic table. Underneath the symbol, you'd see the number 16. That means that each mole of oxygen weighs 16 grams. If each mole weighs 16 grams and we only have 1 mole, that's going to be 16 grams total coming from the oxygen in the molecule. Okay, next, hydrogen. In 1 mole of NaOH, we would have 1 mole of hydrogen. How do you know? At the bottom right of the H, no number is written, so it's an implied 1. Go to the box in the periodic table. Underneath hydrogen is written the number 1, so you'd write 1 there. Each mole of hydrogen weighs 1 gram. Because we only have 1 mole, it'd be a total of 1 gram coming from the hydrogen. So you can plug this in a calculator. The number of grams in NaOH is going to be the sum of all of these. So it should be 23 plus 16 plus 1, 40. So that would be 40 grams of NaOH in 1 mole of NaOH. So let's take this, shrink it a little bit. Now we can bring this up here. Okay, so now we have a plan. We can use the liters, we can use the molarity to get from liters to moles. Now we can use this new conversion factor to get from moles of NaOH to grams of NaOH, which is what they want. Okay, so let's do the conversion. We'll take the number that they give us, so that's 2 liters. Every time you do a conversion, write a multiplication sign, a fraction bar, and the units you start with always go on the bottom of the fraction so that they'll cancel out. So here, that is liters of solution. So we're going to take the part of the first conversion factor that has liters of solution and put it on the bottom there. And on the top of the fraction, we'll put what is on the other side of the fraction bar in the conversion factor, 1.5 moles of NaOH. So you can see how liters of solution would cancel out. You'd be left with moles of NaOH, but we want grams of NaOH, so we do another conversion. Every time you do a conversion, write a multiplication sign, fraction bar. The units you start with go on the bottom of the next fraction so that they cancel out. So that's moles of NaOH. Now we're going to fill that fraction in with our next conversion factor, and the side of the conversion factor that has moles of NaOH is going to go on the bottom, so those units can cancel out. Going over the fraction bars, like going across the equal sign, and on top you'd have grams of NaOH. You could see how moles of NaOH will cancel out. We'll be left with grams of NaOH, which is exactly what we wanted. And now we just have to plug this into a calculator. So you would take 2 times 1.5, enter, divided by 1, enter, times 40, enter, and I'm getting 120 grams of NaOH. So there'd be 120 grams of NaOH, that's sodium hydroxide, in 2 liters of this concentrated 1.5 molar solution. Okay, so the trick here, this is mostly a regular conversion question where you use the molar mass to go from moles to grams. The only new thing is that you're using the molarity as a conversion factor. So break the molarity down into its simpler units and use that as a conversion factor. So let's try that with this next one. Again, in all of these, they're asking for grams of the solute. The solute is the thing that comes after the capital M. So here, they want grams of KCl, potassium chloride. And what they give you are 4 liters, so that's the number that they give you that's all by itself. The other number they give you is the molarity. They give us 0.2 molar, so we have 0.2 molar KCl, potassium chloride. So the first step is to break that molarity down into its simpler units. Take the number that's in front, that's going to go on the top of the fraction, so 0.2. Remember that molarity is moles of solute per liter of solution. SOLN is an abbreviation for solution. When you say per liter of solution, that's per each liter of solution, 1 liter of solution. And so now we have this that we can use as a conversion factor to get from liters to moles. Okay, so that's our first step. We can see the connection between liters here and liters in the molarity, and we can use that conversion factor to get to moles. But what we want is not moles, what we want are grams, and so we need a conversion factor that relates moles of potassium chloride to grams of potassium chloride. To relate moles and grams, you need the molar mass, the mass of 1 mole. And to get that, we'll use the periodic table. So first, list out each of the elements you have. You have potassium, you have chlorine. Look at the compound. If in every 1 mole of KCl, we would have 1 mole of potassium. How do you know? At the bottom right of potassium, there's no number written. That means there's an implied 1. To find out the mass of each mole of potassium, you would go to the bottom of the box in the periodic table and you would see a 39. So you'd have 39 grams for each mole of potassium. You only have 1 mole, and so that'd be a total of 39 grams coming from the potassium in this molecule. Then, for chlorine, in every 1 mole of KCl, you would have 1 mole of chlorine. And you know because at the bottom right of the chlorine, no number is written, and so it's just an implied 1. Go to the box in the periodic table. You'd see that underneath the Cl is 35.45. So each mole of chlorine weighs 35.45 grams. Since we only have 1, that's going to be 35.45 grams coming from the chlorine. Now the compound has both potassium and chlorine, so the mass of 1 mole of the whole compound is going to be the sum of all this. 39 plus 35.45, punch that into a calculator, you would get 74.45 grams, grams of potassium chloride in 1 mole of potassium chloride. So that gives us a new conversion factor that we can use. Okay, so now we can take the number they give us. Every time you do a conversion, write a multiplication sign, a fraction bar, and the units you start with will go on the bottom of the fraction so that they cancel out. So here that's liters. Now we'll go to our first conversion factor, and we'll use the side of it that has liters, and we'll bring that down there. On the top of the fraction, we'll use the top of the fraction of our conversion factor, so that's moles, and you can see how liters cancel out. We're left with moles of KCl, but we want grams of KCl, so we do another conversion. Every time you do a conversion, write a multiplication sign, fraction bar. The units you start with on top go on the bottom of the fraction so they cancel out. So here that's going to be moles of KCl. So take the side of the conversion factor that has moles of KCl and put that on the bottom of the fraction. Going over the fraction bar is like going across the equal sign, so on top we'll have 74.45 grams of KCl. You can see how moles of KCl cancel. We are left with grams of KCl, or grams of potassium chloride, and we just need to punch this into a calculator to get a number. So 4 times 0.2, enter, divided by 1, enter, times 74.45, enter, divided by 1, enter. I'm getting 59.56 grams of potassium chloride. And so that's the mass of that compound that you would have in 4 liters of this concentrated of a solution. Okay, last but not least, C. Now the idea here is the same. We're going to write the numbers they give us down. We'll use the molarity as a conversion factor, and then we'll use the molar mass to get from moles to grams. So they give us 25 milliliters. They also give us 6 molar HCl solution, and what they're asking for in all of these is grams of solute. So here our solute is the same thing that comes after the capital M, HCl. So we're looking for grams of HCl. Okay, first step is to take your molarity and break it down into simpler units. Now remember, molarity is moles of solute. So here moles of HCl per liter of solution. Whatever number is in front of the M, that number goes on top of the fraction. That's how many moles are in each liter, per liter of solution. So the number 1 goes on the bottom. Now we can look for connections. We'll see that milliliters and liters kind of connect. First we'd have to convert, and so you'd want to remember how milliliters relates to liters. There are 1,000 milliliters in every 1 liter. That's a conversion factor you would want to have memorized. So you could see how you could get from milliliters to liters using this first conversion factor. Liters of solution to moles of HCl using the second conversion factor. And then we just need to get from moles of HCl to grams of HCl. And we can do that by finding out the molar mass. The molar mass tells you how the moles of a compound relate to the grams of that compound. The molar mass tells you the mass of each mole, each 1 mole. And to find that, we can use the boxes on the periodic table. So the first thing you'd want to do is to list each element you have. We have hydrogen, we have chlorine. In 1 mole of HCl, we only have 1 mole of hydrogen. How do you know? At the bottom right of the hydrogen, no number is written, and so you know it's just an implied 1. Look at the box on the periodic table. Underneath hydrogen is the number 1. That means that each mole of hydrogen weighs 1 gram. Because we only have 1 mole, there's just going to be 1 gram coming from the hydrogens in this molecule. Okay, next. Chlorine. In this compound, if you have 1 mole of HCl, you would only have 1 mole of chlorine. How do you know? At the bottom right of chlorine, no number is written, and so there's just an implied 1. Look at the box in the periodic table. Underneath Cl, you'll see 35.45. That means that in each mole of chlorine will weigh 35.45 grams. So each mole weighs 35.45 grams. We only have 1 mole, and so there will be a total of 35.45 grams coming from the chlorine. HCl is both of these together, so add them up, and there will be a total of 36.45 grams in 1 mole of HCl. Okay, now we're ready to do the conversion. We can take the number they gave us, that's 25 milliliters. Every time you do a conversion, write a multiplication sign, fraction bar, and the units you start with will go on the bottom of the fraction so they cancel out. So here that's milliliters. So we go to the conversion factor we have that has milliliters, we take that side and put it at the bottom of the fraction. Going over the fraction bar is like going across the equal sign, so on top we're going to put 1 liter. You could see how milliliters will cancel. You're left with liters, but we want grams of HCl, so we do another conversion. Every time you do a conversion, write a multiplication sign, a fraction bar. The units you start with on top, here liters, will go on the bottom so they cancel out. So we go to our next conversion factor, here. We take the side that has liters and put that on the bottom, because we want liters to cancel out. On top, we'll put 6 moles of HCl. You could see how liters cancel out, and we're left with moles of HCl, but we want grams of HCl, so we do another conversion. Every time you do a conversion, write a multiplication sign, a fraction bar, and the units you start with on top, here moles of HCl, will go on the bottom so that they cancel out. We go to the next conversion factor. The side that has moles of HCl will go on the bottom, again, because we want them to cancel out with the units that we have in the previous fraction on the top. Going over the fraction bar is like going across the equal sign, so on top of this fraction we'll have 36.45 grams of HCl. Moles of HCl cancel out, and we are left with exactly what we wanted, which is grams of HCl. We just have to plug this into a calculator. So 25 times 1, enter, divided by 1,000, enter, times 6, enter, divided by 1, enter, times 36.45, enter, divided by 1, enter. I'm getting 5.4675 grams of HCl. So that's how many grams of HCl there would be in 25 milliliters of a 6 molar HCl solution. So to review, the new thing in problem 16 is using the molarity as a conversion factor. By knowing that molarity is moles per liter, you can convert from liters to moles or from moles to liters. Aside from that, you can just use the molar mass to get from moles of the solute to grams of the solute, or you can use metric conversions to get from milliliters to liters. And that lets you figure out the mass of solute in a certain volume of solution.